Let's talk about a non-contagious epidemic, an illness that diagnoses 14.1 million people in the world each year, and is a turn-of-the-century disease that kills 8.2 million every 4 seconds, and is expected to increase twofold by 2030. So let's talk about cancer and my ideas adding on to a progressing solution. Cancer is the abnormal growth of cells that leads to the development of tumors, and if left untreated, cancer can take over the body through the bloodstream and kill. Types of cancer include melanoma, which is the cancer of the skin, leukemia, cancer of the blood, lung cancer, pancreatic cancer, and more. In the last decade, scientists have tried to come up with cancer therapies, submitting over 185 US FDA-approved drugs. The real challenge, though, was that most recent cancers were able to adapt and survive against the body's ultimate disease defense, the immune system. Researchers have figured out a way to combat all types of cancer, well, not yet, but most types of cancer with immunotherapy. Immunotherapy is a type of cancer treatment that strengthens the immune system first, then targets cancer cells. It has less harmful symptoms than chemo because it uses substances that's familiar to the body. And also, if you have cancer, make sure immunotherapy is right for you. I'll be discussing the 3 different types of immunotherapy treatments. I'm going to be comparing to chess, yes. What I'm going to do is I'm going to imagine that the rook, the pawns, the knights will represent the 3 different ways of immunotherapy treatments. And they're going to, with small steps, attack the red king, or the object of the game is really to catch the king, which is the cancer in this case. The first immunotherapy treatment I'll be talking about are monoclonal antibodies. In chess, I like to think of these as the rook. The rook is the chess piece that goes diagonally to the target. I like to think of that as going straight toward the target head on. So that's what monoclonal antibodies do. They're proteins familiar to the body that will directly attack cancer areas. If we look at the picture below, I've drawn a tumor, which is a cancer area that needs to be treated, and these asterisks or stars represent the monoclonal antibodies being injected into the body. Now, because they directly attack cancer areas, these asterisks or stars will go directly to the tumor or cancer areas, and they'll treat that area. The next immunotherapy treatment I'd like to talk about is the vaccine. We already know that a vaccine is used to prevent lots of diseases. In this case, we can use it for, cancer. I like to think of vaccines as the knight in chess because usually a lot of chess players like to bring out the knight in the beginning to deliver a dynamic move. So the reason why we use vaccines first is to prevent all of the complications and hardships with cancer along the way. What happens is the vaccine introduces cancer-like stimulants into the body. So when cancer actually comes into play, the body can defend itself by strengthening the immune system. Otherwise, the vaccine can help cancer prevention. The third and last immunotherapy treatment I would like to be focused on is the checkpoint inhibitors. In my analogy, the checkpoint inhibitors are depicted by the pawn. Now by themselves, pawns have very limited power. In chess, they can only move forward or diagonally once and really never go back in terms of movement because, they can't. And usually these players don't like to use the pawns because by themselves, like I said, they're useless. However, in accumulation or in a great number, pawns can overpower the king. Let's look at this real life example. First of all, we have our immune system, and our immune systems have checks and balances. If these checks and balances are provoked, immune cells are shut down. The inhibitors are provoked most of the time by cancer cells. Cancer cells produce molecules such as PD-1 and its ligand structure PD-L1 to disengage immune cells. Now the accumulation or the pawns of PD-1 and PD-L1 made by the cancer cells are powerful enough to shut down the immune cells. But in the next section, I will tell you how the buildup of molecules can really benefit us. To counter cancer cell molecules, our inhibitors in our immune system make PD-1 and PD-L1 antibodies. Now, PD-1 stands for programmed death. Specialists can create more PD-1 and PD-L1 antibody molecules to inject to our patients in labs, or the doctor can remove some immune cells, culture more of the antibody molecules, and place those producing immune cells back into the body to help raise immunity. Now, the accumulation of PD-1 and PD-L1 antibodies reactivates the immune cells, which were initially shut down by the cancer cells using the actual PD-1 and PD-L1 molecules. How do they reactivate the immune cells? Well, the antibodies trigger the antigen receptors of the T cell, and it'll attack the cancer. In this demonstration, I'm going to tell you how the T cell, or the lymphocyte I was talking about, or the cells that detect and go after and eliminate cancer threats, have the receptors triggered by these two antibodies. Remember, I talked about PD, or programmed death 1, antibodies. There's also the antibody of PD-L1, which is the ligand structure that accompanies this molecule. And both of these molecules actually go to the T cells. And usually there's actually another antibody that goes within the solution. It could be like CTLA used for melanoma, but in this case, to simplify things, I'm not going to add that. So when the PD-1 antibodies and the PD-L1 antibodies interact with the T cell, its receptors are triggered. Now, once these are triggered, it's like a long-term memory kind of thing. It's going to be there. It's going to recognize, okay, well, I have the instructions on how to identify and eliminate future cancer cells. So this is a great approach of a lifelong cancer treatment. Combining all three immunotherapy treatments together, I got my solution. I'm going to add the monoclonal antibodies, the vaccine, and the checkpoint inhibitors together to form the triple-end immunotherapy treatment. In detail, the checkpoint inhibitor enabling will include me to add the PD-1 antibody and the PD-L1 antibody into my solution so that when injected, my solution will help the T cells in the body recognize my solution, and after recognition, the T cells in the long run will identify which are the cancer cells and terminate them. Also, the drug will be injected into the target area, as I said before. The drug will be absorbed by only the cancer cells because the solution has a special protein that binds only to abnormal cells through endocytosis. The drug will then kill cancer in each specific cell. Meanwhile, the drug will be mixed into the bloodstream, which enhances the anti-cancer immunity of the body, fending off any cancer that might have spread or will come, like a vaccine. So how does my solution set myself apart from other solutions? Well, I did some research and I came across bitter melon. Bitter melon is a fruit that contains tambofixin, which is already used in endocrine therapy for breast cancer, and an adenine monophosphate protein kinase. These natural chemicals are proven to lower the proliferation of cancer cells substantially and induces apoptosis, or the death to targeted cancer cells with antibodies. The bitter melon specifically targets pancreatic cancer, but applies to all cancers like lymphoma. There was a study by the Colorado University of mice who had cancer. One was fed regular water as a control group, and one was fed bitter melon extract. After 6 weeks, the study showed that the cancer growth of mice who drank the bitter melon juice had 60% less growth of cancer than those who drank water. If the bitter melon works on mice, it will work on humans. So, overall, in my solution, I will be using bitter melon extract. Thanks for watching. I hope my video explains more about cancer research and my solution to you.